Yes, good morning all. I think all of you installed the MATLAB. So we will see about the MATLAB SIMULINK software. Okay, fine. So what is MATLAB? MATLAB software, I think you people have also in your college. So MATLAB, it is nothing but the matrix laboratory. So by using the matrix with the mathematical expressions, we can solve any problem, and with the mathematical expressions, we can design all the models. So I shared one document, right? So the same document regarding that content, we will discuss and we will design the Simulink model today. And before that, we will see the basic examples about the MATLAB, how to utilize the tools and what other tools are available. And here we are using 2016A MATLAB version. Already MathWorks people, they developed and they released 2020B version also. So here, what happened before this MATLAB, we have Fortran language. So, but to understand the programming languages, engineering students, graduates, or scientist people, they are feel somewhat difficult to understand and to analyze the programming. All the people are not good at programming skills, right? So, with the mathematical problems or with the mathematical equations, how we people can build a model, how we can build a new model, how we can design the model by using the equations with the MATLAB. Later, they developed www.mathworks.com. So from that also we will get more information regarding this. And MATLAB, it is not a open source. MATLAB is a licensed version tool only, and the cost also very high. It's around 5 to 10 lakhs, depending upon colleges and depend upon the industrial persons. They will give the license version. And here, most of the automobile companies also, they are preferring the MATLAB Simulink software. So here, with the MATLAB, how to build the model, we will see here. We have in MATLAB Simulink software, we have more than 100 toolboxes. In 2016 itself, we have more than 100 toolboxes. So we can utilize, if you are good at any toolbox or four tools, if you are good at whether Simulink or Sim Power System or Control System Toolbox or Fuzzy Logic Toolbox, so then it will be sufficient, or we can make and we can place a good company also. Regarding the automobile companies, so most of the automobile industries, they are preferring to design the models or to analyze the models. They are using the MATLAB Simulink software. So here, how to build and how the MATLAB will give the solutions to the power system, and how to design and how to analyze the model, we will see here. Look at here, what are the things we can develop, which industries they are preferring the MATLAB also. Not only automotive industry, artificial intelligence industry also, biological systems also we can develop by using the MATLAB. And in aerospace application, to implement a spacecraft or to analyze the dynamic of the particular system. In the aeroplane also, we people are using the motor, right? And the wings, how to design with the mathematical, dynamically, how to build that model by using the MATLAB Simulink software. Okay, in this industry also we can utilize in robotic system or communication system analysis. And now we people are all using the social media apps. So by using the social media apps, we are doing, whenever we are taking the snaps, we are doing filtering, right? So through that image processing toolbox also available. By using the image processing toolbox also, you can analyze the program with the program, and you can develop a new software. So all industries, most of the industries, they are preferring the MATLAB simulation. And here, especially in our domain, electrical domain, if you are good at to solve the mathematical skills, and you can know how to build the model, how to design the model by using the inbuilt blocks. MathWorks, they will provide in the library different inbuilt blocks. By using those inbuilt blocks, how you can build your own model. How you can build your own model. Here we will see block diagram editing, non-linear simulation. We have integration, differential equations, and number, whatever the equation we have, we can build that equation by using the Simulink inbuilt blocks. And here all the mathematical operations. So we people will study the M1 and M2, right? Math operations, whether the matrix operation or multiplication or division or subtraction, all the mathematical analysis we can done by using the MATLAB software itself. And here monitoring system, financial application also, we people can utilize the MATLAB software. And ship propulsion system, to analyze the water tank system in real-time system, whatever the objective we are observing in our surrounding area, if you are observing that one, the same model we can build by using the, with the equation, we can build here itself. So here asynchronous and synchronous simulation, and with the integration with the MATLAB, and what are the blocks we people will prefer here, we will see here, and we will design. All of you, if you are installing the MATLAB software, just to open the MATLAB software. All of you can see here, this is the MATLAB Simulink software. Look at here, this is MATLAB 2016 A version. So here, this is command window, and this is workspace, and here the command history, and this one current folder, and this is the current directory.
Screen is not visible.
Not visible. Wait a second. Yes, now it's okay, right? Now visible, all of you?
Now it's okay, sir, visible.
Yeah, okay, fine. So now you can see here, this is a command window and current directory path, and this one is a current folder. So you can give, see here, cd current directory path. We need to follow with some commands. So if you need to know this one, so all of you create a folder in your lappy. So you can create a folder. So by creating here, day2, I created EV workshop. So then I copy this current path. This is the current directory path. I just copy this path, and here I enter. So here itself, I entered users, OneDrive, desktop, EV workshop, day2 session. So then here, you people just give here any inbuilt command here, cd, then enter here. Current path you will show, and here which folder you people are using, pwd. All of you give the command here, cd, then enter. Wait a second. Everyone visible, right? You can see here current directory path. So if you are keeping the command cd, then here which current directory path you are using, it will show. And if you are using pwd, you can see here it is showing busy. The path it will show. If you are entering the command cd, the path it will show. And here all of you give the command here. You can see here which path here we are using, which path it is showing, right? Suppose if you are using computer, the command, if you are using computer, which version you people are using, whether 64-bit version or 32-bit version, it will show. Look at here. So Win64 here we are using. So then if suppose if you are entering, actually if suppose here I am taking a is a variable name and here I took a matrix. Look at here. So here 1 4 4 8 semicolon, and you can give here 9 6 3 semicolon 7 5 2 here I am giving. So then close the bracket. All of you visible? Suppose if you are not visible the screen and this letter size, now you can see here, go to preferences, how to increase the font size in the command window. So go to here preferences, click on preferences, click on preferences, click on preferences, you will get one pop-up, you will get one pop-up, you will get one pop-up here. Click on preferences. Now here we are getting the pop-up, right? So now you can see here MATLAB command window preferences. So in this command window preferences, I need to increase the font size. So you can click on the fonts and here you can keep either 24 or 18. So how much you need to keep? So if you are keeping 12, then the font size minimize, right? So here select this part or go to preferences and here click on the font size preferences. Here I am keeping the font size 24. Now you people are visible, right? So if you give the semicolon, if you give the semicolon, it will stop to show the output. So it is a 3 by 3 matrix, right? If when I given the semicolon, it stopped to show the output. So here just enter A, then enter. I given the command here A and 148963752. Suppose if you need to add or if you need to multiply, so here A plus 2 I am giving, B is equal, B is a variable name, A plus 2 here I am giving. Then you can see here. All of you visible? My screen is visible, right, everyone? Now you can see here, B is equal to A plus 2. Suppose if you need to draw the graph, bar graph, so bar B, matrix B graph here I need to draw. So bar B graph here I given, then enter. Then you can see here, we will get one graph, bar graph of the three-phase matrix. We will see here, it's showing busy. Then you will get the figure. You can see here, bar B. Bar graph, and if you need to draw the plot graph in between A comma B, so just give the command plot and open bracket A comma B, that's it. You will get the graph in between A comma B also. So here I given the command bar, then B, bar graph we will get here. Wait a second, it will show. If you need to find the rank of the matrix, so then just give the command rank of A or rank of B. If you need to find the rank of the matrix, you just give the command rank of A. Suppose if you need to observe A transpose or B transpose, give the command A transpose. You just give transpose. Then you can find the transpose matrix or inverse matrix. All the mathematical operations we will do by using this elementary operation, mathematical operation we will do. The same thing we can apply in the MATLAB SIMULINK library also. We'll see here the bar graph. Got it, all of you? Then rank of, if you got the graph here, figure you will get the figure you will get. From that figure, the what is x-axis and what is y-axis and what is the title of that graph. If you need to give the some title for that graph, so you just follow the command. Look at here. Now you can see here, all of you. Look at here, all of you, visible bar B. So now if you need to see here, you can see here. So then what is x-axis? Here I need to write the name x-axis, y-axis, title here I need to keep matrix. So here you people give the command here x label, open bracket, x-axis. We just give the command x-axis. Okay, x label, open bracket, x-axis, you can give the command. So then enter. Then you can see here y label, open bracket, apostrophe. You can give the name y-axis, then enter. Then here title you need to write. So title, give the command title, open bracket, so matrix, or if you need to give the college name also you can give. Okay, matrix, then enter. You can see here. x-axis, y-axis. Now you are visible, x-axis, y-axis, title of the graph, matrix. Title of the graph, matrix here. Visible, graph visible. All of you visible, graph. All of you look at here, visible, everyone. This is about the MATLAB command window. Okay, fine. Okay, so x-axis, y-axis, matrix. Now you can see here, whatever the variable name a or b, if I give, we are getting here a comma b, right? A, b here we are getting. So here, whatever you are entering in the command window, if you need to observe in the command history, now you can see here, I given cd computer here a b is equal to a plus 2. Here I given the right, whatever the commands here I am entering, all it is showing in the command history. Okay, so how to, if you are unable to see the command history, go to layout here. You can see here this toolbar, you can see here top side layout. Click on the layout. Click on layout. You just click on layout. Now you can see here layout at show current folder, workspace, panel titles. You can see here tool tree, command history it is showing up. If you need to close this one, so you can click here closed. If you need to see, now it is closed, right? Command history is closed. Now you can see here, go to layout, command history, then you can click on docked. So now the command history is visible. Command history is visible here. Okay now? So let's see here. So now I need to clear the command window, whatever here I am entering. Now you can see here, give the command CLC. So the entire command window will erase here. Now you can see here, if you give the command clear all, so workspace will be cleared here. You can see here, right side, workspace will clear here. It's showing busy, so then it will erase. Got it? So now, what is the maximum length of the variable name we can give? So actually A is a variable name, B is a variable name, like that we given, right? The maximum length, how much we can give in the MATLAB means, so up to 63 characteristics we can give the variable name. Up to 63 characteristic you can give the variable name. So to observe that one, just give the command in the command window, name, length, max, then enter. Name, length, max. We just give the command in the command window here. You just write name, length, max, then enter here. It will clear here. Wait a second. Got it? Cleared everything?
Yes, sir.
Yes, now you can give the command here in the MATLAB command window, name, length, max. You just give the command, then enter. Name, length, max. 63 character 6. Give the command. So this is about MATLAB command window and workspace and command history, current folder. Now, so here whatever we are entering in the command window, the same thing if you are copy like this, so then here script file is also available. We can work on two ways, .m file and SLX format also. Simulink most probably in our more design model, everything we will discuss on the Simulink library. So here, if people are visible the Simulink. So click on this Simulink. Click on this Simulink. Start Simulink. Start Simulink. We just give the double click here. Start Simulink. Now we'll show what are the inbuilt blocks are available in the Simulink toolbox. So here you can look at here. The PPT, after this, I will share this, whatever the basic level I am teaching. I will share all those things. Now you can see here the bar graph. You can give the command like this also, you will get it. Okay, so then after this, so here we can analyze the 2D graphs and 3D graphs also we can analyze by following with these commands. So here we can go to the Simulink. All of you open the Simulink. Simulink, then take a new file, blank model. You can take it blank model, take it blank model. Now you can see here in workspace, everything clear here, everything clear here, right? Now we can see here name, length, max, enter. So up to how many characters? 63 characters you can give as a variable name. So you can see here 63 characters. If you type here, then you can give the command here any vector. So then enter here. Up to 63 characters you can give the variable name. So here I am clearing the command window. So now click on it, Simulink library, double click it. So then here you will get library browser. Like this, you will get library browser. You will get the blank model. You can see here. How to build the model by using these Simulink blocks. How to build the model. You can see here, from here to here, Simulink library only. If you are working on purely mathematical model, so then this toolbox is sufficient to work on it. Suppose from Simulink toolbox, aerospace engineers, they can work on here. Aerospace toolbox set is there, audio system toolbox, communication, embedded system engineer, DSP system toolbox. Now, we have more than 100 toolboxes. So then in these toolboxes, if you are good at Simulink and Simscape or SimPower system, so that is sufficient to learn MATLAB perfectly, and you can design all the models, the fundamental basics you can design by using these inbuilt blocks, and you can do the real-time simulation analysis also. Now you can see here from commonly used blocks. From commonly used blocks, here what are the blocks are there? In commonly used blocks, so input, output port, ground block, terminator, constant block. Here the difference we need to know: mux, multiplexer, bus creator, bus selector, a demux block is there, right? So by using these blocks, how to build our required model. So from Simulink, and a continuous blocks you can see here. Continuous and dashboard, discontinuous, integrator, we have integrator limited block is available, and whatever the document I am sharing to you, so in those document also the wheel speed trying to reduce means, here in the simulation design we are using the integrator limited blocks only to limit the speed of the wheel, or to limit the speed of the vehicle, or vehicle velocity, angular velocity they given, right? So from that, by using these Simulink library blocks only, we will develop that model. And derivative block, differentiation, integration, zero pole, and here you can see here transfer function blocks is there. So by using any transfer function, you all the control system you have, first order, second order control system you have, right? So from this control system also you can develop the model. So here, suppose you have Bode plot and Nyquist plot. You have Bode plot and Nyquist plot, right? So simply the same Simulink library browser, here you can see RC branch, you people will know, right? RC branch. So series and series you are connected one R, then parallelly you are connected C. Now you can see here. Wait a second. So for a simple example I will give by using the commands. You can see here. Visible, this one. Suppose here resistance and capacitance, here we are connected. From this you will get one transfer function, right? This is V in and this is V out. From this you will get one transfer function, right? So this is R and this is C. Suppose this resistance here I am taking 100 ohm and the capacitance here 0.01 microfarad here I am taking. So if you analyze this one, you will get one transfer function V out by V in, right? So T is equal to RC, you can write, right? So here C is equal to what I said? C is equal to 0.01 microfarad, right? E power minus 6. So then enter. C is equal to 0.01 e power minus 6. Then here, what is R? R is equal 100 ohm, then enter. We can observe here, R is equal 100 ohm, I enter. So small t is equals to RC I am taking. RC here I am taking. R into C. Multiplication C here I am taking. So then you can see here. So this is t. So here now numerator by denominator, transfer function. Numerator by denominator. Numerator command here num. Numerator command here you need to give numerator is equals to here. Numerator is equals to 1 here I am giving. Numerator is 1. And denominator command here del. Denominator command here. So denominator is so t comma space 1 here I am giving. Visible everyone? Now you can see here. So transfer function, how you will write system? I am giving the command system SYC. So transfer function command you need to give TF. Okay. Open bracket. Numerator comma denominator. So then enter here. Numerator comma denominator. It's showing busy. You will get the transfer function. You need to give the command TF, transfer function. Wait a second. So to identify this transfer first order transfer function, or you have control system second order transfer function also available, right? So this first order transfer function, Bode plot also you can find out by using the command Bode. BODE, if you give an open bracket system, if you are giving means, then you can observe the graph, phase and magnitude. Wait a second. So all the control system toolbar, all the control system closed loop and open loop transfer functions you have now, root locus analysis and time response analysis, frequency response analysis, and state space also you have, right? State space separate 7th chapter, right? So from that also you can design the models and you can build it. And the same thing here, whatever the math operations and whatever here we are doing, by using the SIMULINK library browser, by using the SIMULINK library browser, we will build the models. We will build the models. You can see here, by using the same, whatever we are doing in the library browser, in the command window here. Now you can see here, now you are getting system 1 e power minus 6 plus s1, right? This is first order transfer function only. You can derive KVL up. You can apply the equation. If you've done mathematical also, you will get like this. So now you can see here, body of system. Body of system, then enter. Body of Bode graph, Nyquist plot, Bode graphs, you have, right? So from this, you will get it. In the library browser, also you have transfer function. You can see here, transfer function, PID controller, transport to delay, zero pole order. These are the inbuilt blocks. So how to utilize these inbuilt blocks for your model, for your particular model? How to utilize by taking these inbuilt blocks, how to design your own model. So and here discontinuous, discrete blocks, logical bit operations, lookup tables available, math operations. So whatever here we are doing the math operations, by using the inbuilt command like this blocks you have, by using these inbuilt blocks, you can develop here. You can see here math operation square root. Suppose you have x square plus bx plus c is equals to 0. To find out the roots of that equation, you have one formula, mathematical formula you have. The same formula if you are built by using these Simulink inbuilt blocks, you can give the command, you can give the variables a, b, c. Suppose you have y is equal a plus a square plus b square plus 2ab. That is one equation. So if you need to build that equation, so you need to take the blocks, and if you're designing means if you're entering a, b value, then according to that you can get the formulas. We will design the model. Wait a second. So MATLAB, it is almost 8 GB. So if you are using the, when you are working on in lab, it will take time actually, simulation time, it will take time. So we will design the model, that anti-lock braking system we will design for the wheel and how to reduce the wheel speed and the vehicle speed also. So by using the integrated and the Simulink inbuilt blocks, so hydraulic lag, and they are given in that document they mentioned here, with the math operations or mathematical equations, we developed this model. Whatever the model here we have, we can look at here. You can see here this anti-lock braking system we will design by using the inbuilt blocks. Okay, so here when you people are studying about the machines, asynchronous machines, in that asynchronous machine, what you people will study? The asynchronous machine, squirrel cage type of induction motor. When you are studying the squirrel cage type of induction motor, when you are giving the supply to the stator, what will happen? When you are giving the supply to the stator of that particular machine, then the motor started to rotate, right? So when it started rotating, magnetic field it will develop, right? So when RMF it will develop. So then it will try to rotate with some speed, synchronous speed ns. The motor is running with some speed, synchronous speed ns. So then it try to cut the flux. It will try to cut the flux. When people are cutting the flux, induced EMF inside of the rotor, when you are cutting the flux, induced EMF develop, right? Induced EMF when you are developing, then induced EMF it will try to give, or it will try to produce the rotor currents. Inside of the rotor also you have rotor currents. That rotor currents, what it will do? It will apply some force to the shaft of the motor. It will apply some force to the shaft of the motor, and the torque or shaft of the motor, it will try to rotate with amount of speed nr. Rotor speed with nr it will rotate. What it will do? Nr is always trying to catch the synchronous speed, right? Nr is always trying to catch the synchronous speed, but the rotor speed is always less than the synchronous speed. So if the nr is equals to the synchronous speed, what will happen? Slip becomes to 0. Slip becomes to 0 means then the motor will be in ideal condition. The motor will be in ideal condition, right? So our ideal condition or standstill condition, right? So the motor will not rotate if the slip becomes. So when in our academic area, so slip is equals to ns minus nr by ns. You will study it, right? The same here in the vehicle speed also. When you are trying to control the vehicle speed, whatever the brakes, when you are applying the brakes of the vehicle system, first the wheel is trying to reduce the speed. The wheel, you need to control the vehicle wheel. When you people are able to control the vehicle wheel only, the vehicle will comes to reduce the speed of the, you can reduce the speed of the vehicle also. So on the road surface, at least when you are applying, suppose if you are applying 20% of the brake, you are traveling 80 kilometer speed or more than 70 kilometer speed, then any obstacle comes, you people will apply the brakes. When you are applying the brakes, at least you people will travel some distance, right? The condition, how the vehicle, when you are applying the brake system, how the vehicle will, the brake system, we will design how the wheel speed is trying to reduce its speed. So when you people are able to reduce the wheel speed of the vehicle, then the vehicle will directly comes or near to the wheel speed only. So those things we designed here, the same inbuilt blocks by taking the inbuilt blocks. So it will related to why I am telling the squirrel cage type of induction motor. I means here also the vehicle speed and the wheel speed. Vehicle, and here the concept here we are given the slip concept. So that's reason for understanding purpose I given that I discussed that point, and you can compare with that one. So once again go through that document. We given the clearly mention that document, the wheel speed subsystem, what it will do. First we will do the wheel speed subsystem, how to design the wheel speed and how to conclude with the anti-lock braking system finally. This model by taking the Simulink library browser, we will see here. Now you can see here, everyone visible? Here I applied the command Bode, right? So when I'm applying the command Bode graph, you can see here. You are visible, right? Everyone? Now you can see here the Bode diagram of first order transfer function. First order transfer function. Now you have in control system second order system also here. Omega square n by s square plus 2 zeta omega ns plus omega square m, right? So if you need to draw that diagram, so if you know the parameter values, what is omega n, 2 zeta omega ns. So all the things you can develop and you can derive the transfer function from like this only. You need to give the command same here. Whatever the commands here, wherever you need to multiply, you need to do. So here like this you need to give. What are the variables are there in the second order system? From that you can develop this one. So here transfer function we are getting, Bode diagram here we are observing. So here I am clearing this one. All of you taken the library browser. Now you can see here, by taking the Simulink library browser, all of you take the block, inbuilt block. Anyone have MATLAB? Any one of you have MATLAB? Any one of you have MATLAB? Anyone is operating? I can see here. So from commonly used blocks, or math operation also. So in the math operation also you have different type of inbuilt blocks: summation, addition, subtraction, sum of elements, and bias, weighted sample time, slider gain, product block, division block. You have different type of inbuilt block. How to build the model? So here for simply we will take one small example. So then we will build the wheel speed system also. So now you can see here, I will take one sine wave here. I will take here one sine wave to the model. You can see here, I am taking a new model. We have sources. From sources, step block, ramp block, and crypt signal, random number. So, and here pulse generator is also there. Pulse generator. To give the switching signal of any converter, we need to take this pulse generator. So here, by using the pulse generator, we will take, and if you have a differential equation, step response of the system, if you need to do the same thing here, you can develop by using the step block. So you have forward pass and closed loop pass are there, right? So you can utilize the response of the system. You need to find means you can give this step block. Wait a second. All of you take a new model. You can see here, blank model if you are taking, in the middle part, blue or yellow line is there. So you can double click that one, Simulink library browser, it will come. So this is like this, you will get the Simulink library browser. So anyone, if you have MATLAB, I will try to show from here. I will stop the screen. You can share the screen. I will try to give the commands. You can build the model, any one of you. Will you share the screen? Hello. Any one of you can share the screen? Just for you people will get some idea about already. If you know well about this basics means no issue. So if you know, if you don't know means then it will be useful. If you are able to share the screen means you can tell me. I will stop the screen. Few minutes you can share the screen. Then we will discuss it. Can you share the screen? Okay, fine. You can see here. So this inbuilt block, we will develop it, the wheel speed, and these are the blocks we need to take from the library browser. So then we will build it. So the wheel speed subsystem, inside of the wheel speed subsystem, what are the blocks are there? How to create a subsystem, we will see here. How to create a wheel speed. So and here we have bang controller. So here you can keep or you can set the limits and you can try to reduce the limit point on the wheel speed, how much you need to balance. Here you can do, then hydraulic lag transfer function you need to take, then brake pressure. When you are applying the brakes, then you will give some force. So by using that force, and it will apply to the tire torque also. What is the wheel radius? When in your vehicle, what is the wheel radius? And here, then by taking the integrator limited block, you can control the wheel speed. You can control the wheel speed. So for this system, how to build in the Simulink model, we will see here. All of you studied, right? That one, whatever the document I shared, you people have studied it. So just keenly observe that document. So from that, whatever here we are designing, all of you take a new file, all of you. Look at here. Now we will take it. Wait a second. And now you can see here. Actually, this is to save the file, and you can see here, save the file. Everyone visible, right? Save the library browser. Library browser, and model configuration parameters, this one, and here simulation, and you can analyze the model. Whatever I said, you can observe here. To make a product, a real-time product, we have software in the loop and processor in the loop, model in the loop also there. We need to design the physical model actually. So here, the basic physical model of the anti-lock braking system for a vehicle we will see here. You can click on this library browser. You can click on this library browser. You will get the model. Now you can see here. So by taking this one here, you can see. So by taking the sine wave, and you can see here, I added the block model. So to this model, I added it. And otherwise you can do here. You just to drag and drop here also. You just drag and drop here like that. Otherwise, right click, select it, right click, add to your model. Just take a sine wave. All of you take a sine wave. All of you take a. All of you take a sine wave from library browser. Yes. Now go to commonly used blocks. Go to commonly used. Yes. Go to commonly used blocks. Click on commonly used blocks. Then take a gain block. Add to your model. Gain block. Then take a scope block from commonly used block itself. Now you can see here. Here I took a sine wave. Then from library browser, from commonly used blocks, here I just drag and drop here. Drag and drop here. Otherwise, right click, add to your model. You can take a sine wave. Now you can see here, gain block you are taken. If you are using the advanced version, from here, once if you know the where the blocks are available, from which subsystem we need to take, then you can directly like this. You can drag and drop. Otherwise, you can search from here else also. Okay. Now you can see here. And here I said you can see here. Here I need to observe the sine waveform. Now you can see here connected. Then look at here. Now from this sine wave, double click it. Then top side you can observe output of a sine wave O of t is equals to amplitude multiplication with sine of frequency plus phase plus bias they are given, right? So here bias they given so this bias I will try to tell you, and you can keep the amplitude frequency same manner, and here you just double click here the gain block, double click it, and you can keep here 3. Apply. Okay, I increase the amplitude or magnitude of the sine wave, right? So here now this is to run the simulation. Once if you are connected like this, so you can save the file means you can save and keep it as a example 1, and you can see here to run the simulation. To run the simulation, you can click on it. You can click on it. So actually when we are in laboratory, people will observe the output waveforms in CRO or DSO, right? But here in the simulation, we can analyze the waveforms also. We can analyze the waveforms and visualize the waveforms. It's compiling initially, then it will start to run the simulation. Now you can see here. Now you can see here the sine waveform you can observe here. You can observe the scope. Double click it, just double click it. You will observe the scope. Double click it. Wait a second. It's taking time. We'll build the model, no issue. Got it? Huh? Visually, you are observing the waveform of sine wave. How much you are giving? The amplitude 3 you are given. The sine wave, it is started from 0. It reaches to 3, then minus 3 here, right? To change the background color, now it is showing the black color, right? So go to here, view. Go to view. Go to view, style. Go to view, style. You can see here, go to view, style, and you can change the figure color. You can see here. Here I am keeping the block, and here I am increasing the width of the figure color. I'm keeping red, apply, okay. Apply, okay. Now you can see here the waveform you are visible. Now running simulation time 10 seconds we took, right? Yeah, now similarly the wheel speed subsystem we need to build. To build the wheel speed subsystem, what are the blocks I need to take? Look at here. Look at this PowerPoint presentation. So in this PowerPoint presentation, a wheel speed subsystem we are taken, right? A wheel speed subsystem. You can see here. In this wheel speed subsystem, we need a transfer function, integrated limited, gain block we need, sum block we need, right? So then again we integrated limited. This subsystem, how to build, we will see here. So now we can see here. Now you people are visible and visualize the waveform, right? You can keep like this. And here the bias, if you are increasing the bias, what will happen? You can see here. The bias, if suppose if you are keeping 2, if you are keeping 2, then apply, okay. Then the waveform, it is started from 2 itself. The waveform sine, it is started from 2. If you run the simulation, then you can observe the waveform. You can run the simulation. Then you can observe the graph here. The sine, where it is started? It is multiplied 2 with 3. 6 it is started, right? 2 3 6. The bias. We can see the waveform, it is started from 3. And the mag here we are giving 3. So 6 to 9, then again up to 3 here it came. Okay. So you just keep always bias value 0 itself. No need to change and no need to think about that. Whenever you are taking the sine block for your model designation, you can keep 0 itself. That's it. So then it will be from 0 itself. Now here I need to build the subsystem model, right? So now you can see here. Go to library browser. All of you go to library browser. Here from library browser, I am taking here, go to library browser, bang controller I need to implement, right? So for that bang controller, you can see here, a relational operator is there. A relational operator, in commonly used blocks, you have relational operator. So take that relational operator, then here data type conversion is there, a data type conversion. So why I am taking this data type? Real world values it will show. Data type conversion, a relational operator here I am taking. You can keep see here from library browser. Then again I need a sum block, right? Sum block. So then we need constant block already. We need one constant block here. Where here you will get constant block. So now by taking this constant block, now you can see here. Here this relational operator, what I said, the bang controller, it will limit the input and output, right? So you can see here greater than or equal to. Double click this relational operator, take it as greater than or equal to. Apply. Okay. You can see here I'm connected here. So then I'm taking I selected this one and drag and drop here one more. You can drag and drop here one more. This relational operator and data type conversion. So double click this one, keep it as a less than or equal to. Okay. So then here you can keep constant and you can connect here itself. You can connect here itself. Double click this constant block and give here 0. You can keep the limit at 0 to and peak value here. So this one visible, you can see here relational operator, here the per port, here we are connected. Okay, so then what we are doing, you can see here sum block here we took, then you can keep positive and negative. So you can keep see here plus and minus I took. Apply. Okay. So then here I connected and this one. By creating this one, Now here select this entire part, select this entire part up to here, select it. So now create a subsystem, give the command Control G in your keyboard, Control G, Control G, create to create a subsystem. Now you can see here we created as a subsystem. So this name you can give here bang control. You can give the name. I given the command what is the bang controller will do. Read that wheel subsystem bang controller. So these blocks, whatever the inbuilt blocks we are given, it will limit to the input and output speed of the vehicle. Now you can see here. Now after this hydraulics or hydraulic lag system is there, right? So here hydraulic in the electric vehicle also now hydraulic brakes there. Now you can see here from continuous blocks we need to take one transfer function. We need to take one transfer function. Now you can see here from continuous block here I took transfer function. By taking the transfer function, you just see here, giving the name as hydraulic lag, then connect it. So and here the values, what are the values they given? Now double click it, the numerator value here 100, denominator coefficient here this one 0.01 space 1, apply, okay. Now this one, so then when hydraulic system or hydraulic lag system, after that when you are applying the force on the wheels, right, brake pressure you are applying, brake pressure, right? So now to give that block here we are preferring one integrator limited block, integrator limited block here we are taking the brake pressure system. Here we can see here to apply the brake pressure in the model simulation we are taking here integrated limited block and we given the name as brake pressure, brake pressure, brake pressure, here we are giving the name. Double click this brake pressure, double click this integrated limited, initial condition here it is 0, upper saturation limit in between 0 to 100 you can keep, in between 0 to 100 you can keep. So now apply, okay. After this when you are applying the brakes you will give some force to the vehicle or force to the wheel system, right? So here you are taking the brake pressure, then you are applying some force, right? Force you are applying. So double click it, give the value here, keep 1, apply, okay, apply, okay. Now what here we are doing, we need to take a brake pressure and the tire torque, actually brake pressure and tire torque. So here we need to give one sum block we need to take. So we need to eliminate this one, right? So double click this one, keep it as negative and positive, apply, okay. Okay, so then again when you are applying the brake pressure or force system, now you can see here again you can take one more this, then you can keep here 1/5 of the speed you are trying to reduce, 1/5 of the wheel speed you are trying to reduce here, 1/5 here I am giving 1/5 of the vehicle speed you are trying to reduce, here I am giving 1/50. Then here at that point when you are giving some force from here to here, tire torque you need to give, that one we will design. So now you can see here, so again here I am taking this one I am giving the name as wheel speed. Wheel speed. Wheel speed. Double click it. Double click it. So here the initial condition of the wheel. The initial condition of the wheel here I am multiplying with the initial speed 88 star 88 star 12 by 15. 12 by 15 it is the RR we are given in the document. You can observe 12 by 15 RR. Wheel radius we given. So 12 by 15 we are given, and 88 in here we can give. The upper saturation limit here we are keeping 0 to 1000. Apply. Okay. Apply. Okay. So then here you will get the wheel speed of the output. So now up to here we have designed. This is the anti-lock or brake design of the wheel system. So select this part. Select this part. All of you select this part. So Control G. Again you can create a subsystem. Again you can create a subsystem. So this subsystem name you can give as wheel speed. Wheel speed. So here what is the now what is input one? Here you need to give the slip, right? How much the relative slip or the desired relative slip you need to give. And input two, what is the input two here? This is tire torque. I said tire torque. Tire torque. Tire torque. And here you can see here out one here wheel speed. Wheel speed. Wheel speed. Now you can come back here. Now you can see here. Everyone visible? Now you can see here. So this is the wheel speed, right? So now you can see here. Now here we need to keep the feedback path system. Again we need to give the vehicle and wheel. This is wheel and vehicle system and weight of the vehicle also. Weight also you need to mention. So now you can see here. Here I took a sum block. Then here I took a constant block. I took a constant block here. Constant block here I took. So constant block here, you just give the name as relative slip. You just give the name as relative slip you can give. Relative slip you can give. Relative slip you can give. You can see here, connect it, and the input one you can see here. Now we need to take the feedback path system, right? The relative slip here I took, or desired slip, 0.2 here. This is the desired slip. This is the desired slip actually, desired slip 0.2. The relative slip is, okay. So then this is the desired slip, sir. Desired slip, right? A desired slip. You can see here. Now here, by taking the desired slip, now we need to, when we are applying the brake system, at least we people will travel at 5 to 10 distance, some distance we will travel. So that one here, again, we need to give 1D lookup table we mentioned. The lookup table purpose here we are taking the test cases, how the wheel and how the wheel is trying to reduce the speed. In how many cases it is trying to reduce the response we need to observe means the analysis whatever we are how much force we are applying the brakes. Apart from that, then wheel is trying to stop, right? So at that point, the vehicle condition and vehicle wheel test cases we need to write and we need to import that data by using the 1D lookup table, one dimensional lookup table. Here we are using 1D lookup table. Here we are taking, look at here, 1D lookup table. Here I am taking, go to lookup tables, go to lookup tables, go to lookup tables. Go to lookup tables. You can see here, go to lookup tables. Go to lookup tables. You can see here, wait a second, MATLAB stuck. Go to lookup tables, take 1D lookup table. One dimensional lookup table, you can take it. That data, the test cases, actually the test, whatever the test data, we need to keep here itself. We need to keep here. Now you can see here from library browser. From here, lookup tables are logical and bit operations. We have lookup tables. From lookup tables, you can take one dimensional lookup table. You can take one dimensional lookup table. You can take. So now you can see here 1D lookup table is there. So just drag and drop here. Drag and drop here. Control or this one. Now you can keep like this. You can keep here. This is the feedback path system. So double click this one, change the sign parameter as positive, negative. Apply, okay. Apply, okay here. So then you can keep this lookup table. Here I am keeping. Then again, I am taking one more gain block here, Control R. And here the weight M star G, the weight here we are representing, the weight here we are representing. Now you can see here, the weight here M star G, right? Now you can see, double click here. So you can keep with 50 star 32.14 by 4. Yes, 32.18 by 4. Here, 32.18 by 4 here you need to keep. Apply, okay. So you just drag like this, you will visible the weight. Now you can see here, you can keep these things. You can keep like this. So now here what I said, from this tire torque or wheel radius we said. So now you can keep here. You can keep the name here, tire torque or wheel radius. You can look at here, a wheel radius. From that wheel radius, you can give the name as wheel radius, double click it, 15 by 12 you can keep, 15 by 12 you can keep, 15 by 12 you can keep. So then here, this is the wheel radius, radius of the wheel. From here, you can generate the tire torque. From here, you can give the tire torque here. Then again, you can take one more gain block here. One more gain block here you can take. So connect it and you can keep here. Now this is here we finished the wheel part. Now here with the angular velocity of the wheel, we need to try to reduce the vehicle speed, right? So here minus 1 by 50 here I'm keeping. And here, then you can see here, go to library browser. From continuous blocks, you can take integrated limited block. You can take integrated limited block. Then you can see here, the vehicle speed you can mention here. The vehicle speed you can mention here. The name here, you mention the integrated limited, and here vehicle speed, right? Just look at here. Look at here. So after this, double click this one. Double click this one. The initial condition here we are representing 88. Upper saturation limit you can keep here 100. And you can keep here saturation port. You can give the tick mark here, saturation port here. You can keep here the tick mark here, saturation port. Apply. Okay. So then, so to stop the vehicle speed, you can give the command here or inbuilt block from sinks. From inbuilt blocks, go to sinks here, go to sinks. From here sinks, you can take stop simulation time, right? So by taking this block, you can stop the distance of the wheel or vehicle. You can stop the simulation. So then we can keep here, take a you can see here stop distance, then here vehicle speed or vehicle angular velocity, right? Vehicle angular velocity. So now here again we are taking one more gain block here, then connect it to here. You can give the name as vehicle angular velocity. Vehicle angular velocity. Okay. So then you can see here. So from this, the value how much here? 12 by 15, right? 1 by RR. So 12 by 15 here we are keeping, apply. Okay. So then take a integrator limited, integrator. From commonly used blocks, you will get the integrator. You can see here. So you can take this one and connect it to here. So now this is the vehicle angular velocity or vehicle speed, and to stop the distance, this one. All these 3 points we need to merge at one point. So if you keep and if you connect here, you can observe the graph of the vehicle speed graph. You can observe here. Then you can see here. So here we need to take a bus creator. We need to take a bus creator. By taking the bus creator, double click this one. But how many input ports here? How many input? 3 input ports. One is wheel and the vehicle. And here the number of inputs here I am taking 3. Apply. Okay. So now you can connect here. you can connect this simulation. The output ports you can connect here. Okay. So after finishing this, now from here itself you need to give the feedback path. You need to give the feedback path to observe the vehicle speed. Take one more scope and you can connect here the vehicle speed. From here you can observe the wheel speed and the vehicle speed. So from here we need to give the feedback path, right? Go to user defined function, take a function block here. Take a function block. So here by taking this function block, you can observe here. Here we will represent the functions. In the function block, you can give the function name as relative slip. Relative slip, you can give the name. So then here from this, you can connect here itself. You can connect the feedback path. Okay. So this is about the anti-lock braking system. In this relative slip, you need to observe the waveform. You need to connect here. Now you can see here, this relative slip, you need to express the here the expression here 1.0 minus of u of 1 u of 2, u of 1 by u of 2 plus u of 2 is equals to EPS, right? Minus u of 1. So here actually sin omega t we will write. Sin omega t here in MATLAB simulation, the u of 1 is represented with the omega t. So here whenever you have omega t, sin omega t, you need to write. Sin u of 1 you can keep. Okay, sin u of 1 by u of 2. So actually the slip is 1. So if the slip, both slips are equal, means what will happen in the vehicle? The wheel speed and the vehicle speed both are equal at when the slip becomes to 0. When the slip becomes to 0, both slips plus u of 2 is equals to, you can see here 0, and you can give the EPS. You can keep here one more bracket and here star EPS, star EPS. Then you can see here apply. Okay. So this is about anti-lock braking system model, the vehicle speed subsystem, and you can keep the simulation time 25. Simulation time 25. Now you can run the simulation and here you can connect to observe the speed. You can connect here display also. You can connect here display also. So you can keep here and here also. Okay. So now if you run the simulation, you will get the output here. So now you can keep the name as anti-lock braking system. Anti-lock braking system, you can keep the name as anti-lock braking system. Now you can see here. Here we are trying to run the simulation. Now you can observe here how the wheel is trying to reduce its speed when you are applying the brake. When you are applying the brake, how it is trying to reduce the speed, you can see here. It is paused, right? So now you can see here. Yes, right? Now you can see here 0.2 is the desired relative slip you are applying. Then you can observe the graph here. We can observe the graph here. Wait a second. Now you can see here the vehicle speed. You can see here the graph here, how it is oscillating. It is trying to reduce its speed, right? Now you can see here clearly how much time it will take. So actually this one we can't visible, right, in real time. When we are applying the brakes, the wheels on the road surface, they are maintaining with some angular velocity. If you are able to trying to reduce the wheel speed now you can see here both graphs I will show. Now you can see the difference from the wheel and vehicle. When you are able to control the wheel or vehicle, wait a second. Now you can see the difference here, both speeds. Waveforms you can observe here, vehicle and wheel. You can see the graphs, both graphs, a vehicle and wheel. So this is wheel actually. This is vehicle and wheel graphs. You can see here. The vehicle, you people are applying some desired relative slip 0.1. What they given in the document also, in the document, if the slip becomes to 0, the vehicle speed and the wheel speed both are equal to each other. Both are equal to each other. Now you can see here how much time and it is taking. The wheel is trying to control. Once if you are controlling the wheel, the vehicle speed you can directly it will come to here. Both are not equal each other. So the wheel speed it is maintaining 37.47 and in between 10% difference is there, right? 46.89 this one. We given more than 70 kilometer, right? 88 by 12 by 15 we are given the wheel speed to try to control. Then you can see here more than that 70, right? So then the oscillation and it is trying to reduce up to 37. At that point a wheel is, so is there any oscillations like this? Now you can see here the graph, you can see here less, right? So within the time, if you are able to control the wheel, within the time the vehicle will be in your control. Okay, it's fine. I will share if the people are little bit fast to try to design, but the blocks, whatever the inbuilt blocks here, so here we are applying only Simulink toolbox only. We are not using anything. Simulink toolbox only we are taking. So with these are the mathematical expressions, we know the parameter values means from that we can take the inbuilt blocks, we can give the values. But for understanding purpose, here we have taken wheel radius RR. Otherwise, you can see here, the wheel radius RR here we are given a, if you observe any research paper also, they will not show the values. So they will keep with the variable name parameter like this, and they will try to hide the values. RR they will keep, okay? So like this they will give RR only. So the parameter values where they will keep now, go to file, model properties, model properties. Here in callback functions, they will write all the values. whatever the equations we have, and from here in this callback functions, we can keep preload function or initial function, post load function. If you need to write some description about the model also, you can write, and you can write the name MSEAC. Okay, so you can keep and you can write some description about the model, and you can keep all the parameter values here itself. Okay, so I will share the model. You just practice once again. I will share the recorded session video also. So if a little bit fast. So once again, if you have query regarding this, you can put a message. I will try to tell in coming session. And for tomorrow session with a basic example and one advanced model also I will try to show, which are designing model. Then we will see how to control the motor actually by using a traction inverter and motor application, how we can control the motor and how to design the feedback system for inverter and the motor. The feedback system, by taking a BLDC motor, the feedback system we will create and we will design it. So I hope you people are got the points. So tomorrow session we will meet again. So that's the reason before 10 minutes if you are entered means then from 10 o'clock itself we can start. Okay, anyhow, so thank you all for participating in this session. So tomorrow we'll meet again. So thank you all. Have a nice day.
Sir, you'll be sharing this MATLAB model and
Yeah, I will share it. I will share it. I will share